You've probably heard that oil and water absolutely refuse to mix. And it's true, they are chemical opposites. So how does a simple bar of soap force them together? The secret is that a soap molecule is literally two-faced. Meet sodium stearate. On one side, it has a long, zigzagging hydrocarbon tail. On the other side, a tiny charged ionic head. These two halves have completely different personalities. The long tail is hydrophobic. It is terrified of water, but loves to dissolve in oil. The little head is hydrophilic. It loves water, but ignores oil. Imagine a stubborn drop of oil stuck to your clothes. Water alone just slides right off its surface. But when soap arrives, its water-fearing tails are desperate to escape the moisture, so they plunge straight into the oil. They completely surround the oil, forming a spiky sphere called a micelle. Because the outside is now covered in water-loving heads, the water is tricked into washing the whole package away. With the dirt securely trapped inside, the water-loving heads on the outside of the micelle take over. They are strongly attracted to the surrounding water, creating a powerful upward pull. Add a little agitation, like scrubbing or the spin of a washing machine, and the dirt script on the fabric finally breaks. The entire micelle lifts off, floating freely in the water. These floating dirt traps are now suspended as a colloid. Because their outer shells are covered in negative charges, they violently repel each other. They can't clump back together, so they simply wash down the drain. But all of this brilliant micelle chemistry completely falls apart if you try to wash in hard water. Hard water is packed with dissolved calcium and magnesium ions, which are basically a disaster waiting to happen for soap. Because calcium has a double positive charge, it hijacks the negatively charged heads of two soap molecules. It locks them together into a heavy, insoluble lump called scum, wasting the soap before it can ever reach the oil. To fix this, chemists created synthetic detergents. They keep the exact same oil-loving tail, but swap the head for a different chemical group that completely ignores calcium. This means detergents can keep forming micelles and lifting dirt, no matter how hard the water is.